It's all forgotten. Second disclaimer. I used to be an insect pathologist, and I used to deal with diseases of insect all the time. And in fact, that was my first job right there. I was producing an insect pathogen, but my objective was to kill insects with that. So this is back way too many years ago. This was back in Brazil where I'm from. By the way, today I brought my wife. She's trying to pretend that she doesn't know me. But if you want to know anything about insect rearing, that's the person you have to talk with. Because she has reared a lot of things. How many cockroach species did you have? I don't even recall. 12 or 15 different species of cockroaches.
17.
How many species of ants did you have?
Oh, at least 10, 12.
So she knows how to rear insects. She never reared a single butterfly, so I don't know if that counts. But anyway, glad to be here again. Apparently I've been here 3 times, 2 live and 1 online.
Glad you made it.
Yeah, I didn't remember all of that. But anyway, yeah, it's good that I went back. So what I do these days is I work with urban insects. And I'm the Florida Pest Management Association endowed professor, meaning the guys that come to your house to kill the cockroaches and ants and flies and mosquitoes, whatever you have there. That's what I do these days. I have nothing to do with butterflies. So let me just go ahead and get through this then. So this is where I started reading this. I worked for the Rhode Island, that company producing the fungus, but then on research I went to work with rice and beans, which has nothing to do with what you did do here either. And eventually I got to the US. But back to our lunch. So you guys have ever seen a sick insect?
Oh, yeah.
Yes.
Everybody.
Yeah. How was the sick insect that you saw? Which insect was it?
Well, usually butterflies,
Mhm.
but I've seen sick roaches,
Mm-hmm.
and I wasn't too sure what's wrong with them. I've seen other ones too.
How can you tell that a butterfly is sick?
About deformities.
Deformities. Okay. That's a good way.
Or
That's a good way.
leaks
Yeah.
or
So, there are a lot of things that will tell you that an insect is sick, right? This here, that insect is not sick. That insect is dead, right? So it's good that you recognize a sick insect, because a sick insect can still be made whole again. Not that you care that much, because the insects are very dispensable, right? You have, 10,000 caterpillars in your facility. If you get one sick, it doesn't really make any difference, right? So what's the best thing to do with that sick insect? Try to make it healthy? No. The best thing is to get it out of there immediately, right? So we are not really in the business of curing insects or making them good, right? The ones that are sick, we will probably want to take it out of there as soon as possible and then go on with our life and business and whatsoever, right? So recognizing a sick insect is really not necessary. It's necessary, but it's that insect, curing it is not the objective, right? The objective is saving the rest of the colony, and that's what we usually have to do and think about. Yeah. So So there are many things that make you sick that are not microbial, right? And you guys deal with all of those things all the time in your rearing facilities. One of the things is just handling mechanical damage to insects, right? A caterpillar usually can take a little abuse. The adult butterfly probably doesn't take that much abuse. It's just damage everything. But so recognizing things that may injure your insects, if it's a piece of equipment, if it's the size of the cage or the type of cage that you're using, those are things that will cause this type of mechanical injury to your insects. And you want to minimize that injury as much as possible. So designing your facilities in a way that it will not allow or will not cause the insects to be damaged is the first thing there. Then there's that physical there, the temperature, the humidity, radiation if it's the case, sun radiation. Have you ever killed a bunch of insects with just being out in the sun, in the heat? That will happen too. But temperature is one of the things that we have to worry about quite a bit. And with most insects, especially if you're trying to grow something indoors, right? And many of you probably do at least part of your rearing indoor. Maintaining a decent level of moisture is always a good thing. Not too much, because if you have too much humidity there, you may end up with problems, especially with fungi that they grow. Some of them may just be on this substrate that you're using to feed your insects, but there are some fungal diseases of insects that may be enhanced by high moisture in there too. That third one is the one that worries, I guess, me and many people, is chemicals, right? You guys probably deal with this all the time, whether your neighbor is spraying their field of blueberries and some of that pesticide is coming over to your facility. So that's always something to worry about. Now, there isn't much you can do about that except talking with your neighbor and explaining to them what you're doing and making sure that they are not doing something that may hurt your insect rearing there. But once that occurs too, once you have an intoxication going on, there isn't much you can't really give these insects some medicine that will cure them very easily, right? And the other thing is even if you could, does it pay to do that? And that's the economical side of the story that I'm not prepared to discuss, and I don't know anything about that, but you guys probably know. So insect rearing is usually a mass thing, especially in butterfly rearing. You're not just rearing one or two, right? Especially if you're in the business of releasing many of these, somebody's wedding or something. Saving one or two is a lot easier than trying to save a whole colony. And if a whole colony is affected by something, you're probably not in good shape anymore. Genetic diseases, that's the one that we can do something about, right? Is the stock that you have, you probably have been growing the same species for quite some time. Who are you choosing as the moms and dads for the next generation? That's the part that we have to worry about is making sure that the parents for the next generation are of good stock. I didn't pay very attention about getting good stock for myself. And that's why I end up short this way. I have to talk about people. But that is to stop, right? That's the parents of your next generation is something that you really have to pay attention to. Especially, there are a lot of genetic things that may happen, and you have to make sure that that is not the case. And then the last one. If you don't get that one, you might as well walk out of here. There's no hope for you, right? Because nutrition is what's going to make your insect beautiful, what makes your insect functional, flying, doing whatever you want them to do, and it's what's going to make it reproduce for the next generation too. So that part there, even though is considered an microbial disease, there isn't much, that I can tell you about except read the books, follow the rules, and do whatever you have to do to give these insects a good stuff. So we are really going to, concentrate on the diseases that are microbial in nature. Okay, and these are the ones that you can try to get rid of, that you can sometimes cure, if not the individual, at least the colony of that disease. And these are things that will invade the body of the insects and can potentially spread through the whole colony. So these are the ones that we're going to be paying attention to. People have known about diseases of insects for a long, long time. Okay. In ancient Greece, they were well aware of diseases of bees. And in China, they were well aware of diseases of silkworm. Those are silkworm right here. Do you guys recognize what kind of disease this has? It's a fungus, yeah. So this is actually from a website that sells Chinese medicine. And they sell these things. These are silkworm caterpillars. They have been killed by a fungus, and they are very hard now. Do you know what this is sold for?
I don't remember what it's called.
Aspirin. Penicillin.
Let me start again. This is a caterpillar that's very hard.
Oh.
You get it.
Okay.
You almost forced me to talk about it. I don't like to talk about it. Okay? But that's what's sold for. Does it work? I wouldn't except that you asked that question. But the other one that we have here is the bees. The disease of bees are very important. You guys know in the business that you are how important bees are in terms of pollination. Is it me? Okay. So bees is another one that people have known of disease of bees many years ago. They are still important. We have an enormous bee lab at the University of Florida. They have been studying bee diseases and other things for quite some time. And there are things that, it's there, but you will never know until it's way too late. I know you guys don't care about cockroaches. This is the German cockroach. And these cockroaches in the lab, just like what we have, they may end up having diseases. And the problem with that is that, if we are doing experiments and trying to see different ways of killing cockroaches or different products that could be used and this kind of thing, if that cockroach is infected with something, whatever results we get are going to be very suspicious, because this is already a compromised insect. So for research, this is also very important. And of course nowadays, and you guys are right in the middle of this, there are very serious consequences of diseases for, things like conservation efforts and other efforts that we have in getting nature back to what it was before we were around, right? So very important consequences that we have to do. So how do you recognize that something is sick? We already talked about, something that's dead is not sick. Recognizing that is no big deal. Little kids can say, "Oh, this is a dead bug." Okay. It doesn't help you much. But there are things that you can look at. And I don't know why this thing is so weird in terms of the focus there. But one of the things is just color. Okay, insects with different things, different pathogens may look a little different. You see there a caterpillar that is a little darker than the normal caterpillar. You have here 2 mosquito larvae, and this is the normal color, and this one here is a little darker, and one that has a virus there. So you guys go into your cages and you're looking at these caterpillars and everything. A good way to detect these things very early is to just know what they normally should look like. If they look a little different, maybe you want to separate that bunch of caterpillars there and not deal with them until the end of the day, and not go into that cage until late in the day when you finish doing everything, so that you don't go into that cage first thing in the morning and then you're going to the other cages all day long, spreading whatever you may have gotten in there. So knowing what they look like, what's the possibility of them having something.
Just a heads up, sometimes in older climates, the mark has a fifth star. The black bands would be much more extensive and the yellow restricted. It looks really dark, not like that. But that's just a natural colorization, at least in my fault, those are the same thing, and those aren't sick. So that's a heads up.
Yeah, and that's important, and it will come up. But yeah, one thing that you have to be very familiar is, what does a good insect look like, right? What is a healthy insect looks like, because that has to be the image that you expect to see. And if something is different, if something is out of that normal, it's perhaps time to pay a little bit more attention to that group, make sure that nothing is wrong there. There are many other things that may occur. For instance, here, these are bees that have a virus that is called the deformed wing virus, because entomologists are so very smart and they come up with these very bright names. So, if you see a butterfly that doesn't quite look right, if the wing is not quite well formed, maybe it's just a mechanical problem with that wing. It occurs, it's not a real contagious disease, but you have to pay attention to that. Normal color, what is the going on? A lot of things in the insect, if there is a little injury, and this is very common in butterflies and caterpillars, we used to cut the little leg of the caterpillar so you can get the hemolymph, and that thing will eventually heal again, but there is a black spot there, and that's one thing that happens. So a lot of diseases that will cause a little injury will leave a darkened spot on some insects, depending on what it is. And of course, there are things that we recognize by the presence of some form of that pathogen that's in there. This cicada up there obviously has some white stuff growing out of it. It's not sick, it's dead, but it's showing the sign of this pathogen. This is a mosquito again there. that it has a microsporidium and it has a swollen thorax there, and you can see the presence of the pathogen there. The animals that I have done much more in terms of diseases is ants, and this is ants that have some nodules inside their body here, and we can recognize that as the presence of these microsporidium diseases that occur there. So, one of the things that happen with insects is sometimes when they are feeling sick, they will try to cure themselves. Okay, and this is what's called behavioral fever. So, how they get to know this is a mystery to me. But this is common. Some work that was done with flies. Flies that are infected with a fungus, they will look for higher temperature, and that higher temperature may actually kill the fungus inside and then allow the fly to live normal. So that's called behavioral fever. So if by any chance your insects are doing something funny, out of the ordinary, perhaps that's their attempt to get rid of some disease that is bothering them. So these are, the graph here shows the percentage of flies that are in different temperatures, and that's what they do. They end up going to higher temperatures just to, an attempt to get rid of an internal infection. How do they know? Now, this is a long list, and I hope you all, have this all in your brain by the end of the time that I will show this slide. But there are many different behaviors that insects go into that somehow will affect the presence or of the lack of a pathogen. And they do many things that will avoid getting in contact with pathogens and or if that they somehow protects them even though they are not really planning on that. So there is that therapeutic medication there. So infected insects exploit species of compounds that could clear. So how do they know? I don't know. But some insects that have some disease may actually prefer plant A than plant B because plant A produces something that allows them to cure themselves of that disease. I work with ants, so social contact. Ants that are diseased, they basically, avoid much contact with other ants. And the other ants also kind of expel them from the nest, right? So this is something that can happen. So there are many different, behaviors that exist that somehow affect diseases in general. Doesn't help you very much, right? Because most of you have captive colonies that are being fed one specific thing, and so this behavior is not necessarily something that you will observe in your colonies, but in nature this happens all the time. This is again coming back to how we recognize which caterpillar is sick and which is not sick.
Straight.
The straight one is sick. That straight one or this straight one? The dark one. Okay. Any other guesses? Can be a wrong guess too. Just like his.
The smaller one that's more scrunched up. Looks like pretty weird. not in like, he's not shaped like that, it's
Yeah.
big, not actual innovator.
Yeah. This is what we call a looper, a caterpillar. So they don't have all those middle lines there. So they actually form a loop before it's a completely normal thing. So that's not the
It's
other.
not the top.
None of them are.
That's not the sick one either.
The one at the top is it?
No.
None.
Yeah, you've seen this lecture before, right? No.
Yes, they know.
And that's the thing about insects, that these are insects from the same colony, the same batch, and they show these two different colorations. The correlation sometimes has to do with the crowding in the facility, but they have this variation too. So again, knowing your insect is very, very important. We have to know that these are cabbage loopers that, well, it's not a butterfly that people would ask for in their wedding, but you probably will never rear any of that. But that's one that a lot of people rear. And of course, anybody from the Northeast here? This used to be a very common thing to see these gypsy moth, and they're hanging down, they're attached to the plant by their legs here in the back, and this caterpillar is affected by NPV, nuclear protein virus. I have the caterpillar, the normal one right there, it's doing okay, and then this is a typical thing for some viruses in caterpillars, that the caterpillars will die, but will be hanging down from the plant. So if you start seeing something like this, be very careful. Take that insect without spreading all that liquid that's inside there, right? Because it's sick, and at that point in time, it's not releasing any viruses, but it will as soon as you break the skin. Yes, sir.
When this happens, is there spores that flies out into? I use Connie's little box, so sometimes I get these. So does that mean like that batch is basically sick now? Because like does the spore explode when that happens?
No, that's the spores are that insect is basically a sack of liquid.
So as long as the juice and then all the dirty stuff didn't physically touch another caterpillar, I can still raise it in
Yeah, well,
in
you have to
theory.
be very careful. But,
Right.
Because there may be some piece of that thing that is breaking that we don't detect. But the virus at that point in time is mostly contained inside that sac, and you have to be careful in removing that so that you don't spread the whole thing in the place. So that's the idea.
But any others I had in my box, I would suspect.
Yeah, if you have, if you have them containing different boxes, and one box comes up and you see a few that have, or one that has disease, I don't know how precious your one box of caterpillar is, but my tendency would be say, this is the box I don't need here, and I will get rid of that. If there is one of that in a cage that has, several of these things that you can't get rid of all of them, then you have to be careful in removing that as careful as if you go there, put a plastic bag around that, close it, and then remove. That may be a better way to go around about it. But breaking that and taking it in a hurry is not a good idea. Yes, sir.
Is with the history of the gypsy moth, is that something that may have been induced, or is that a naturally occurring NPV in it?
It's a naturally occurring, but yes, we did back then, especially in Canada, in Sault-Ste-Marie, there was a lab that was reducing this in very large scale. This became a commercial product at some point in time that people could buy too. So there was a lot of work with that thing as a potential commercial product. It's not a very, if you're going to bet your money on something, this is not because once you spread it around and kill everything, you probably go to 5 years without a client again, right?
Yeah.
So, yeah. But this was done with the governmental agencies and things like that. So, some diseases are very, fast, and you see the results in very few days. This is again a virosis here on some caterpillar that I don't recognize. Cabbage, so things occur very fast and kill the insects very fast. And there are things that are chronic, and to see a chronic disease, you need to have a insect that lives very long, or an insect that a colony lives very long, which is the case with ants. And with ants, we did spread some diseases around the fire ant. For those of you that are not from the south here, fire ants are a big thing. And this is a disease that occurs in fire ant that you can introduce this protozoa into the colony, and it will eventually decline. The colony will eventually decline. The population starts diminishing and everything. But it takes a long time to kill that population. So it's a chronic disease and not very fast. So let's go through some of the pathogens that we may see, starting with bacteria. Bacteria is the one that's, bacteria and viruses are the ones that worry the most because they are harder and they act very fast. But bacteria is very small, and they reproduce binary division, so they don't produce anything outside of the insect in general. And some of them produce spores. So a spore is a resistant phase that can be in the environment for a long time. So if you have one of these spore-forming bacteria, they may be lingering around for a long time. So the most talked about bacterium that affects insects is the famous BT, right? The Bacillus thuringiensis. And BT now is not a bacteria anymore, it's a plant, right? BT core. So what happens to that bacterium is that it produces this crystal that you see here. So that crystal there, when the spore is formed, that crystal is formed. That crystal is made by a protein that basically erodes the gut of an insect. So what we did is now we picked up the gene that produces that crystal and put that in plants, right? And there are some parts of the country that you have basically every piece of corn that's planted there is a BT corn. BT corn is not a corn that caterpillars will eat very much because it contains that protein that will eventually damage their gut. So this is something that you may want to pay attention to. If you're in Florida, you're probably free of BT corn, but many of you are not from here. And there are BT soybean and other plants too. And so now we are producing not the pathogen, but the disease-causing element of that pathogen on the plant. Right? So one has to be careful with that. And there are a ton of BT products that people use in gardens and in agriculture and everything, which is just the bacteria produced in large scale in a tank and then formulated in different products. And people like these products because they are natural, they're organic, right? So people feel inclined to use this around their places. And all of these contain that spore of the spore that for BT, and also that crystal inside there in the product So another thing to be aware, and another thing to talk with your neighbors to see if they will avoid using that thing.
Can I ask a question?
Yes.
So when you have BT, put that in the soil, does that become systemic inside the plant?
No.
Okay. So
So-
if the caterpillar eats a plant that's grown in BT soil, it's not going to be
So-
affected.
What we on the BT plants, it's systemic because it's added to the DNA of that plant.
Right. Those products you just showed, was that a soil remedy or is that for seed?
No, those are mostly for spraying on plants.
Oh, you sprayed on,
No.
okay, I thought it was.
Yes, sir.
So if you spray it on the plant, the caterpillar eats it, will the butterfly move it or a flying insect move it or will it stay there?
It's mostly supposed to stay there, because insecticides are usually formulated that if you apply on plants, they want that to stay there for a while, right, until it gets consumed. So it's made for, if the insect eats that plant, it gets that protein, and that breaks down their guts. So it will be there on the plant, but this gets into the soil too, and it's washed off plants and go into the soil. It all depends on the chance of your insect picking it up from the soil as opposed to from a plant, or a splash of the soil onto the land.
So you're saying it grows more in the soil then?
Sorry?
It grows or stays alive better in the soil?
It can grow in certain conditions, but that's not a normal habitat for
Just don't do soil.
the bacteria to grow.
No problem.
It grows much better inside an insect or some other. It grows well in a
Artificial.
pet dish if you have a nutritional
All the
need.
way. You don't like plants.
So it can grow outside on some material that is providing right nutrition for it. So this is here now another bacterium. This is, you may have done this, seen a red insect in your colony. Have you ever seen this? We would see here when we are rearing cockroaches and ants and other things. Once in a while, you see an insect that's a little red, more red than normal. And that's another bacterium. It's a bacterium that forms this red pigment. It's called Serratia marcescens. This is also a problem in hospitals that are not cleaned very well, because this can grow in a bunch of things. But it's another bacterium that can kill insects. And then just below the bacterium there is the Wolbachia. Have you ever heard about Wolbachia?
Yeah.
Yeah. Because nowadays we use Wolbachia to kill mosquitoes, right? And Wolbachia are bacteria-like things, but they are not quite bacteria, and they do very weird things on insects. And one of the things that they do is they change the sex appearance or the gender appearance of butterflies. And this is an example here that there are several degrees of infection of this insect, and the more infected it is, more male-like it is. So the thing that is not treated, it looks just like a normal female, but if you treat with this Wolbachia, and it will look more like a male butterfly. And in insects in general, there are several different things that may happen with these Wolbachia. And many of these things are just natural in the life cycle of these insects. In some insects, if you have the female infected, like here, there's no progeny whatsoever. If the male is infected, you may have a normal progeny. So it's very weird with these Wolbachia too. So if you do run into a case that there's some weird things happening in your colony and you can't understand, these mayors are coming up and they have both male and female characteristics. They are halfway between the color of the female and the color of the male. It may be something like this because it does messes up, and it has this phenomenon of either killing the male or having what's called the feminization aspect, that the males end up looking like females too. So that's weird things. So, you're probably not gonna run into something like this. In case you run into something like this, call somebody and say, hey, this looks like a Wolbachia thing, and maybe somebody will come and look into the details there. But you have heard about these, weird mosquitoes that they produce today, right? And that's a Wolbachia thing that they have on mosquitoes that in nature the mosquitoes can produce normally. If they use these genetic modified mosquitoes, these mosquitoes will not survive in nature. They only survive in the lab because they put an antibiotic in the medium. The antibiotic kills the Wolbachia and prevents them from acting, and then there's normal conditions. So now, here in Florida, just about every county here in Florida has what's called the mosquito control district, because there are a lot of mosquitoes here in Florida, and some of them are actually producing this GMO mosquito, which is really just a mosquito that has a pathogen that they can control if it's expressed or not expressed in the colony. So, moving on to protozoa. By the way, I can tell you a whole story about diseases of ants, which are much more interesting than diseases of butterfly. This is a disease that we found here in Florida, and because I'm so smart, I called it yellow hand disease. Guess why? In a sec. So that coloration is because it affects the cuticle of the insect, and if you look through that insect, you see the accumulation of spores inside there. So this is, you will understand why I'm showing you this in just a little while. This is another ant disease. It's another Matesia. You see the spores there, and it kills what we call the native fire ant here in Florida. And this is a normal pupa, and the sick pupa will be all black like this. And it so happens that these two diseases are a relative of OE, which you all recognize, right? So it's a fairly close association between those two diseases of fire ants and the one that you worry about in butterflies. And you can see that the spores, we don't see the whole cycle of OE normally, but it should be very similar to the cycle of these two diseases of ants. What we do see is that the spores are very much like the spores of Matesia that I mentioned here. But the weird thing about this disease is that it's growing on the very superficial layers of the cuticle, right? And that's why when the caterpillar becomes a butterfly, that you see the spores, they're right in the middle of the scales, because it's that tissue that was the cuticle of the caterpillar that becomes the wings and the scales on the wings, and that's where you see these spores right there, right? So very similar disease with the same complicated cycle that we see in ants, you see in butterfly here. And you guys know the diagnosis of this is very simple because this is a weird disease that the spores of this disease forms outside of the body, right? It's gonna be among the scales of the wings, so it's very easy. You can just get a piece of Scotch tape, put on the wing of the butterfly, put it under a microscope, and you will see the presence of the spores there. Actually, if your eyes are a little bit better than mine, and you're a little younger, you may actually see the spores, in the Scotch tape very easily there. So you don't have to do much to examine these things. And this disease, I'm pretty sure you guys are very aware of this. It has a very big, effect on that migration dynamics of the monarch. You see that a butterfly that has to fly that long, it should be in top shape, right? It can't be weak in any way. So it's very likely that that butterfly never makes it all the way down to Mexico because it's not going to be very good. So it ends up that it has a very interrelated dynamic between the disease presence and the migration, and this is but you end up that in these non-migrating population, there's a chance that this can actually accumulate and start killing many more butterflies that way. So the sick insects are not reaching Mexico, which is good, right? Because then there is a population to come back. And in a way, that migration kind of eliminates the disease in great part. If we start having resident populations, have you ever heard of anybody keeping butterflies, monarch butterflies for a long time? You have to be careful with that, right? Because you have that population in that same place for a long time. Then the next group are fungi. I'm a fan of fungus anyway, but the fungi have a tendency to be very showy, right? Because they grow out of the insect. They don't stay inside like the protozoa, like the bacteria. Those are doing most of the growth and the reproduction inside the insect. The fungi have a tendency to burst out and say, hey, I'm here, I'm reproducing, and that's what forms these showy effects, including things like this, that if you are from up north, you may have seen a little fly stuck on a window pane, a glass pane, and around that fly there's a little halo of white stuff. What that white stuff is, like here, is these are spores that were shot out of that insect. So these fungi produce spores and they expel them and then forms that ring around the thing. So next time you're in Cornell or some godforsaken place there up north, you can see this in certain buildings, a fly that dives on the window and has this little, actually I've seen that in Gainesville, Florida too, so it's not, it's very common in other places. So fungi do this all the time. Why am I having a little battery on my computer?
Matt.
I don't know. So some of these have this funny growth. Look at this. There it is. Thank you.
Oh.
Jake.
Hopefully it's coming. Any questions so far? It's coming back. Any questions?
There used to be a program where we could send our caterpillars off to be tested. Do you know if there's any place that we could do that now?
No, there is no place. You're probably aware that Mississippi State used to have a insect disease diagnosis service. And the person that was in charge of that, the professor, passed away, and that was transferred to Amanda. You may remember her name, and Amanda was running that for a while. Departments of the entomology, as they are today, they are just like everybody else. They are going molecular for everything, right? So in many cases, you walk into an entomology department, and there isn't a single living insect in that department, and the diagnosis went on the same way. It's not something that is prioritized by the university. The fact that you have a cockroach guy here talking to you about insects, diseases, and butterfly tells you a whole lot. That there has to be some understanding, possibly with the pressure of you guys, on whatever university or USDA or whatever service it is, to provide that type of service for you.
Would you say that again? I mean, I can just barely hear you, and this is very important to me. I've been searching for someone that could do this for us, and I've been having a conversation. I don't want to miss it.
Yeah, no, the fact is that, there isn't much I can do, right? I do insect pathology as a hobby more than anything else. I should be taking care of people and I usually am talking to people that are doing pest control of roaches and cockroaches and ants and other things, and I'm not talking to butterfly people. And I'm not a specialist on this. And there is a need, and the only way that need is going to be satisfied is if people that are interested in this kind of thing talk with their representatives, talk with their universities, talk with their Congress people or whatever to provide that service. The USDA is probably one of the places that could provide that service, but the University of Florida could provide that service, or just like the University of Mississippi used to provide that service. But we probably don't need that in every single state, right? Because they're, as important as you are, you're not that much of a business interest that every single state may have to be providing that service. But there is a need for that service. And actually, you have a good ally now, which is the industry producing insects as food, right? Both for pets and for human consumption. And that industry will also need somebody that can provide some service in terms of diagnosis or lectures or whatever it is, presentation on diseases of insects and how to deal with them and not. I unfortunately am not that person. My position doesn't cover this at all. I love to talk about it. I love to show you these nice pictures because this is my first love.
Are most universities equally equipped, or are there some that you think might be better to approach?
Well, when I started in college, in my graduate school here in the U.S., every single major department of entomology in the US had a course in insect pathology, and most of them had a professor that was specialized in insect pathology. You will be hard pressed to find any of these universities that have a person specialized in that now. And people like me that were specialized in that now, I am not in a position of making this presentation here. It's not within my area of expert of responsibility within the university. But so it's only through your own effort that this will happen. Yes.
But you're saying that if there was a Save the Cricket program somewhere that the university was interested in, a Save the Cricket program, those are the people that we would approach to say, hey, would you do this for us? Because those people would be fighting the same kind of bacteria, but just in a different insect.
Yeah.
So maybe we just have to find some kind of an insect that people want to save.
Yeah, but you guys work with insects that people want to say, right? And so you were probably in a better position to advocate for that than, I work with fire ants. Who the heck wants to save the fire ants? Right? So the only approach that I can have with disease for fire ants is that I want to produce more diseases and find more disease to kill these fire ants. Right? Your needs are a little different.
But we did have a cricket crisis back in, I think it was around 2012.
Yeah.
Where there was a cricket shortage and a cricket crisis and nobody could feed their crickets.
Yeah. But again, the number of people that produce crickets is not that very, very big. The number of people that produce caterpillars and butterflies is much bigger. You guys have the insects that people really care about, right? The only reason I care about crickets is because we feed crickets to cockroaches. Okay? You guys are dealing with something that is a little bit more personal for people, that's a little bit more valuable, right?
And a lot of reptiles use them too, because we feed them to all the airplanes.
Yeah. And so there is a need both for from the side of the production of insects for animal feed, production of insects for human food, and production of insects for whatever other reason, all the reasons that you do it, all of this is important. So I'm sorry I can't provide you any better news than this, but it's good that you are aware of that fact, and that's what you have representatives and state officials and so on and so forth. Don't tell them I told you. But anyway, let me just go on here. I'm not here to preach. I'm just here to teach. So I was talking about fungi, and fungi, they usually invade insects by landing on the cuticle, and you see there that insect spore has germinated, and that fungus goes directly through the cuticle of the insect. And together with the fungi, there is this class of organisms that's called the microsporidia. Microsporidia is like a bacteria that wanted to become a fungus but didn't quite make it, so it's got stuck right in the middle. They probably don't want me to talk about them like that, but they like the bacteria, they will land on a surface, but instead of start multiplying, they actually have this germination tube here, and that penetrates the body of the host, and that's how the organism will penetrate the host. And they kind of cause all sorts of different problems in different populations, including Lepidoptera. And these are the things that are called Leucina and Veromorpha. Those are the most famous ones in the group. And these occur in very different types of organisms. Here's some caterpillar, Heliotis zeta, corn worm, and it forms spores that are very similar to bacteria, but usually the insect ends up a little swollen and doesn't fall apart like the bacteria will cause an insect to body to disintegrate. So controlling bacteria, microsporidium is very similar to the control that you do with the Artesia disease, the OP disease. It's usually good to separate the females that are not infected and do all of this, destroy cohorts that are infected, because otherwise you end up contaminating the whole place. And then there are viruses. The only thing that I can talk about is the fire ant virus, because it was the first virus that appeared. But in caterpillars, there are several different viruses: the NPVs, the GVs, NPVs, the nuclear granulosis virus, GV granulosis virus. They all do about the same, and they disintegrate the insect. This insect becomes very flaccid, very full of gooey stuff inside, and usually it can decimate a whole population in very few days. So if you see anything like that, you have to move very fast. Viruses are terrible. Nematodes is another one that you may see in your colony. They are little worms, and they basically proliferate inside the insect body, and then the body falls apart, and these little worms. She's saying hello to me. Hello to you too. And nowadays there's a little bit more of these microbial insecticides being used. This is, for instance, bad bugs there's a fungus that people use. There's the DT for plants that have caterpillars. Also another BT that's used for control of mosquitoes. So there's quite a bit of these microbes that are being used out there. So be aware of what is being done around your place. Of course, the BT that affects mosquitoes will not kill a caterpillar, but it's good that you know what's going on there. And this is just to show that BT, what's killed is not the bacteria itself, is that the crystal there that really disrupts the cuticle and so on and so forth. Just because I work in the area of health, I just want to make you aware, because you all work outdoor, that these diseases that we used to hear about occurring in Africa, they are coming back. Here in Florida, we have had 9 cases of locally acquired malaria. Have you ever met anybody?
My dad, 3 times.
He doesn't work here. Where does he work?
He was born in Paraguay.
Oh, Paraguay.
Yeah.
It's a terrible place. It's too close to Brazil. It's too close to Brazil. In Paraguay, in Brazil, where I come from, malaria is a fairly common thing. In Brazil, there's a lot of dengue and chikungunya, and we have had our number of chikungunya and dengue here. Malaria is a little bit worse disease, and so you guys work outdoors, be aware of these things so that you don't get caught. This is just a warning, and this is my email address. I'll be happy to help you with whatever I can, but I don't have a diagnosis service, and it's up to you to get somebody to get that diagnosis services